Welcome to the module on the science of fat gain. It's important to understand the physiology of how we actually gain fat in order to have a better understanding of how to mitigate fat gain and reverse it. So naturally, this is the module that precedes our fat loss programming module. And so the goal is to get a solid foundation on how we gain body fat in the first place. So let's begin. So with lesson one, we're going to define obesity and look at the implications of something called metabolically healthy obesity. Second lesson, we'll look at appetite regulation. In lesson three, we'll look at fat balance and fat cell dynamics. And then in lesson four, we'll look at something called the carbohydrate insulin model of obesity, since it has been presented as an alternative explanation for fat gain. And then lesson five, we'll look at the impact of overfeeding on body composition. And then lesson six will wrap it all up with the big picture of programming. Okay, so let's talk about defining obesity and also discussing the implications of metabolically healthy obesity. The formal definition of obesity was put forth by the National Institutes of Health, and it's based on body mass index. So body mass index is body weight, total body weight, in kilograms divided by height in meters squared. So that's the formula for deriving BMI. And the NIH put forth the cutoff points for the various body weight categories based on BMI. So there's underweight, normal range, and then overweight. And they did the same thing with three different classes of obesity. So class 1 obesity begins at a BMI of 30. Class 2 obesity begins at a BMI of 35, and class 3 obesity begins at a BMI of 40 or beyond. Now, it is very important to be familiar with the limitations of using body mass index. So what body mass index can be useful for is as a rough, very crude population level screening tool for risk stratification. What it is not useful for is a way to assess individuals. And this is because BMI does not take into account body composition. And the problems that you can run into with using BMI as some sort of hardline parameter of risk or status is that there are many individuals who happen to be, for example, in the overweight category of BMI of 25 to 29.9, but these individuals just happen to have more lean body mass than the average. And so that's where things get treacherous when you use BMI on an individual basis. You run into problems with a lot of the physically active and certainly the athletic populations that carry an appreciable amount of muscle mass. Let's talk about reasons for fat loss and weight loss. And so one of the popular and obvious reasons is just beauty, vanity. And then there's losing weight or fat for sport or competition in weight class-based sports, for example. And then, of course, there's the various reasons that fall under the umbrella of health. And we're talking about not just physical health, but also mental health. So this table right here, it gives a projection of the obesity prevalence, what it might hit by 2035. And it's kind of a pretty alarming and concerning prognostication that we're looking at. So I want to highlight the proportion of the population with obesity. As it stands right now, we're around 17% of the total population that has a BMI of 30 and up. And by the year 2035, that number is projected to increase to 24%. And so, unfortunately, obesity prevalence is projected to keep increasing. And that's a bad thing for very many reasons. Okay, so I think it's also important to talk about how the human species is more or less hardwired to store body fat. And this is for, among other reasons, one of the fundamental drives of the body is to just survive. And in fact, that's arguably the strongest drive of the body is to survive. And so in the case of we humans, those of us who are better equipped to store energy and use it in the event of a famine are better equipped to survive from an anthropological standpoint. So, what I have here in front of you is the International Society of Sports Nutrition position stand on diets and body composition, which I lead authored a few years back. And I just want to read you an excerpt from this paper because I think it's important and I think it captures better what I'm trying to convey here. So, when hypocaloric conditions are imposed, energy expenditure has a tendency to decrease. Conversely, when a caloric surplus is imposed, energy expenditure has a tendency to increase. However, human energy balance has been called an asymmetric control system because it tends to be lopsided in favor of more easily gaining weight but less easily losing weight. This asymmetry has been attributed to evolutionary pressures that selected the survival of, in quotes, metabolically thrifty individuals who more easily stored body fat during times of famine. So, thanks to our ancestors who were able to survive famine from being metabolically thrifty, we essentially inherited a greater propensity to gain fat in a tougher time to lose fat. But it's for the purpose of being able to survive. Let's talk about the concept of the metabolically healthy obese or metabolically healthy obesity. And so defining this is it's being phenotypically obese, in other words, fitting one of the BMI classifications of obesity, but having little or no evidence of metabolic dysfunction. In other words, the absence of metabolic risk factors that are out of range, like, for example, blood glucose and insulin sensitivity parameters that are out of range, as well as blood lipids that are out of range, high blood pressure, etc. And so without these biomarkers of health being out of range, but we still have a BMI that falls under one of the categories of obesity, class 1, class 2, or class 3. And so that's what's considered metabolically healthy obese. Now, here's the misconception. Metabolically healthy obesity does pose health threats, but not necessarily in the present time. So the misconception is that there is no risk to being metabolically healthy and obese. The reality of the matter is that it has a poor long-term prognosis. So metabolically healthy obesity still requires intervention. And that's because about 50% of individuals who have metabolically healthy obesity, about 50% of them will cease being metabolically healthy roughly within 10 years. So it's not necessarily about a snapshot in time in the present. It's about the long-term trajectory. So even though there is a type, a phenotype, if you will, of the metabolically healthy obese individual, there is still a poor long-term outlook, and intervention is still a smart thing to engage. I want to make a little note about class 1 versus class 2 versus class 3 obesity. So in certain sports where the individuals carry an extraordinary amount of lean body mass, one can argue that you can still be within the category of class 1 obesity, in other words, a BMI of 30 to just under 35, but still not be carrying inherent threats to health. And so the individuals that come to mind are athletes in the heavyweight division of elite sports. You can think of combat sports, you can think of strength and power sports. And so in the case of combat sports in particular, heavyweight boxers. A lot of them fall under the BMI of 30 to 35 ish. And so they'd be classified as having obesity under the BMI stratification system. But a lot of those individuals are, in fact, metabolically healthy because of their physical activity levels and because they are not in these higher classes of obesity, class 2 and class 3, that pose a much more robust inherent risk to health in the long term. And with that, we conclude the first lesson, and I will see you back for lesson 2 when we talk about appetite regulation.